M.Tech in Control System from REC Kurukshetra in 1994 and his doctorate from IIT Roorkee in 2007. Since 1995, he has been a faculty member at MNIT Allahabad. His research interests include power quality, e-mobility, smart metering, AI application in power system, energy management, and smart grid. He has published more than 140 research publications in peer-reviewed international journal and conferences, and co-authored of 3 books and 20 book chapters. He has also organized several short-term faculty development programs focusing on various power system issues. He has delivered 60 lectures at various national and international forums. He has supervised 15 doctoral and 64 master theses. Also, he has procured research funding of over Indian rupee of 2 crore since in the year of 2015 from various international and national funding agencies. Currently, he is a senior member of IEEE, a life member of the Indian Society of Technical Education, a life member of the System Society of India, and a fellow of the Institution of Engineers. Professor Singh is also a recipient of the Outstanding Energy Award Engineer Award in the year of 2020 of IEEE PES UP Section Chapter for his outstanding contribution to the power engineering profession. We are truly privileged to have presence and expertise with us. Please, sir. Thanks.
हाँ ऑन करिए वो चलिए सर थैंक यू वेरी मच महिमा फॉर दिस इंट्रोडक्शन so I have been given this assignment to deliver a lecture on this integrated electrical grids with IBRs, right? So we will talk about what are IBRs, where they are in our grid, how they are affecting our grid, what changes they are bringing to our grid, right? I think yesterday, day before yesterday, we are aware with the IVR what is it and how they are functioning in the power system. That has been covered by the earlier speakers. So, what are IBRs, right? So, you can find that there are two different types of sources in the power system. One is synchronous and second is non-synchronous, right? So, these IBRs are those which are non-synchronous. Synchronous means we call them synchronous machine or synchronous motors or synchronous generators like this. Are you aware with this or not? Right? But this new generation resources which are being used in the quest of this addition of renewable energy where we are trying to decarbonize the grid, right? So we all know that nowadays our grid is going through a transformation under the impact of 3Ds, right? What are those 3Ds? First is decentralization. Means we are earlier what happened in earlier days when this power system started, we put all these generating stations at a central place where the generating either the generating resources were available. What were the generating resources? Resources for the generating stations were either water or coal, etc., etc., right? So either they were close to the stations, generating stations were close to the this load, or closer to the availability of raw material for the generation. Clear? So that was the era when we started doing the things in a centralized manner. Clear? And another point which went into the support of this centralization when we tried to do it as a centralized way, that the cost of per unit electricity was decreasing when we are making it in a larger way. So that was the time. You will not. I hope you must have seen the power plant, thermal power plants or something. Have you visited or not? How many of you have not visited thermal power plants? Not visited. Have you visited any power plant? Thermal, hydro, or hydro? Which plant? What was the capacity? No idea. So that was making electricity using flowing water, right? So there must be a turbine, and that turbine, under the impact of flowing water, when water flows into it, that converts it into this energy. Which energy? Potential energy is converted into electrical energy, right? So this electricity generation, as we say now, so this all is a energy conversion basically. Do you agree with it or not? So we all know that energy transformation takes place. Energy form of energy changes, right? So let me give you one assignment. You just note it down in your copy, right? What, in how many ways the energy is being converted in thermal power plants where you are making electricity from coal, means the energy is stored in coal, and how this stored energy in coal is converted into electricity, that is another form of energy or electrical energy. Agreed or not? So there will be some n number of stages between these two, means in this transformation process. Agreed or not? Right? Similarly, you can also consider this hydropower plant, how this electricity is, or how this energy is transforming into electrical energy in case of hydropower plant and nuclear power plant, right? Then you can tell me in that question, answer of that question, how I am talking about these three I have told you, right? Among these three, which two are closer in functioning or similar, more similar in functioning? Clear? So these are three questions for you, right? This answer you shall think on it. If you do not want to submit, no issues. You must be aware with the answer. The question is clear or not? Right? Okay. So, so this was the story when this came into the centralized generation, right? But when this era of renewable energy came, or we started talking about the this net zero impact, or we have started talking about the pollution or climate change, etc., etc. So there were n number of resolutions were made at the global level, right? That is not the discussion topic today, but I'm just touching it today. Clear? So what happened? Then we started thinking about generating electricity from the renewable energy resources, right? Then second term came, we will go for this decentralization of generation. Means we will generate electricity closer to the point of consumption, right? So what we started doing, some this small electricity generation at this hydro plant or thermal plant, something like that. But you must be aware that you will not find any thermal power plant in the range of 100 kilowatt or 200 kilowatt. Agreed or not? But there were earlier, ठीक है, आज से 30 साल पहले, 33 decades or 4 decades before, this Panki thermal power plant, where I did my training during my this BTech days after second year, that was having 3 units of 100 into 3, 100 megawatt into 3, right? And right now you will not find any unit less than 500 megawatt or something like that. Is it or not? So this is the transformation which has taken place, where the centralization of electricity means larger electricity generation at a single generating station took place, right? And what we are doing now, we are talking about entirely opposite to that, where we are trying to generate electricity closer to the point of consumption using this solar panels at our rooftop, using these wind turbines in our closer vicinity, or simply these small hydropower plant. You will not believe the government has given license for several hydropower plant which are generating in the tune of 1 megawatt to 5 megawatt electricity in the Uttarakhand, right? And another new point is that even NTPC, which is the National Thermal Power Corporation, they are bidding for it. Right? So there is no classification now कि नहीं this particular company cannot go for the another mode of generation. You will find that near Unchahar, when you are crossing this Lucknow road, you will find that there is a board and NTPC is owning some solar power plant of some 10 megawatt. It is an old story. They maybe updated them, right? And there are solar power plant right now which are generating electricity in the tune of megawatts, right? We call them solar park, right? Another question is for you: what is the largest solar power plant in India? Answer is not required here, right? You must be aware with this, right? It will increase your knowledge. Number 2, within this 200 kilometers of Allahabad or 300 kilometers of Allahabad, maybe 250, are there any such solar power plants? Right? Some 2 years back or 3 years back, our Prime Minister inaugurated similar plant in some very close vicinity in that radius of distance which I am telling you. Right? So you must be aware with those things. What is renewable energy generation, right? And wherever this renewable energy generation is taking place, they are coming under this category of inverter based resources. Agreed or not? Right? Because this generation is taking place in one form of electricity, and for consumption you have to process it in some other form of energy, electricity. So in this process, during this transformation process, in the last stage of generation, this comes or make it useful for the users of the consumers, right? This is IBRs are very much present in the system. Clear? Second, what was earlier story? Earlier story was, in earlier days there was a power system book. Used to be every power system book was having the questions like this. This is the load curve. If the load is following or load is increasing in both ways, how many number of generators you will have to start, or how many number of generators will be required, and extra generators you will have to make off, right? So that was the period when the centralized power generation stations were there. We used to call this phenomena load following generation, right? Load बढ़ेगा, generation will increase, load will decrease, generation will decrease, right? Now the scenario is different. Today's scenario, I am having a rooftop solar plant, right? I may or I may not have electricity connection in my house. My work will go on. If I am using battery energy storage, why this battery energy storage is used, right? So with these renewable energy resources, it is considered that they are technically dependent upon the climatic conditions. Wind is more, wind generation will be more. Solar radiance is more, right? Solar generation will be more. But there may be time when the scenarios may be vice versa, right? And there may be conditions when your requirement of electricity is more, right? But your generation is less, right? Second, there was a problem. This generation was that much dynamic in nature, right? Without battery storage, it was not possible to make them dispatchable, right? Dispatchable means I want to send this much power. I have a commitment as a power generation company with some client, and this much power is required. And if I am totally dependent upon these renewable sources, then there may be situation that I may not have that much generation, right? So these battery energy storages, they make this dynamic generation or non-constant generation dispatchable. Clear? So this is the term you shall remember. What is the usefulness of battery? Battery makes the renewable energy generation dispatchable. Clear? Number 3. Now, the time when I'm saying you that we are in the era when we are using this renewable energy generation, so we are what we are doing? We are trying to be generation following load situation today. In the morning, there is a forecast of the climatic condition, there is a forecast of the solar power generation, there is a forecast of other type of non-conventional generation. Clear? Non-conventional means renewable. Is it or not? Right? And there are problems, several research is going on the load forecast also. If today is this much climatic condition, hot, cold, whatever that is, what will be the load requirement tomorrow, right? Or day after tomorrow. Clear? There are considerations for holidays also. There are considerations for working days also. There are considerations of some match or festivals also. There are consideration of during this day time. There are considerations of some popular TV shows also, right? They have to consider all these things. This 8 to 9 is the most prominent TV serial time, right? So these may increase the load. Clear? Because right now the balance of the generation and consumption is all this difference is going to decide the price of the electricity. Are you aware or not? I think Dr. Prashant has taken this consideration, right? So this difference in generation and consumption, that shall not be much more, right? Because this difference, either generation is more, in that case you are not going to get the price of the unused electricity, right? If the generation is less and consumption is more, then the utility companies may be liable to paying some penalty for that. Clear? So this characteristic is going to be very very critical for these scenarios, right? Because this all cost which the company is going to bear, that is going to be passed on the customer. So if the company will book loss, so they will not be in the business after some time, or if they are not caring of this loss, it means the customers are going to bear this price. Agreed or not? So that's the reason this particular domain of electricity is under research. Clear? So you as an electrical engineer who are planning to do some research in future or planning to do some project for your BTech or MTech courses, you may take this dimension, right? This is a very interesting dimension where mathematics and your favorite AI and ML techniques, they are also have applications there. You can be a part of that thing. So this is just a motivation how to attract you towards the power system engineering. Means problems are here also where you can apply this AI and ML. Clear? Chaliye. So IBRs are basically solar PV, wind turbines. Wind turbines especially type 3 and type 4. What is the difference? I will cover in the next slide. Then comes BESS, that is battery energy storage systems, right? They are battery or some energy storage system in general also. Clear? And then fuel cells, then electric vehicles also. Because what is electric vehicle? Electric vehicle basically is battery on wheels. Agreed? Means if you want to use it as a load, it is grid to vehicle. If you want to use it as source, it is vehicle to grid and it can participate in this complete ecosystem of the electricity. Agreed or not? So key characteristics are with this non-synchronous power sources is they provide no natural inertia but can support grid services. What are the new grid services? Earlier the grid service was only to provide electricity, right? No other function this grid system was doing, and it was there only they have to provide this electricity at with some specifications. This much voltage band is there, etc., etc. And most important thing they used to take care of, the power factor shall not go low, right? And it was never beneficial for the consumer to take care of this power factor, and that's why this responsibility was only with the utility, that they used to maintain this power factor, right? And earlier, these utility companies or generate the substations, they used to have this capacitor, right, installed at their substations, right? Can you tell me why this is beneficial for the supply company to maintain good power factor? Do you have answer? Hmm? Have you studied the course on power system? Have you studied? It's a very simple answer. No, sir, it's a very simple answer. Okay. In which course you are? Oh dear. Which college? Okay. Have you covered this first year course? Have you studied that Excel and XC calculations? Have you done those things? Have you done this power diagram, power triangle, active power, reactive power, and okay, you just draw that in your copy. Can you draw it? This is a triangle having one angle of 90 degree. Just draw it. एक सब लोग ड्रॉ करें प्लीज. Draw a right angle triangle and put PQS, right? P is the active power, Q is the reactive power, and S is the apparent power. Yes, you know it. Just draw it there. Have you drawn it? Okay. Just put a relationship between them, among them, all three. Okay. Right? So we all know that the quantity which is generated, this is what among these three? In S, P and Q, what is the generation? S or P or Q? What is generated? P and Q. किसी के दबाव में जवाब तो नहीं बदल रहे हो? ठीक है. Let me tell you one more question. One more question is, have you gone through the ratings of generator, alternator, or that turbine which you are just telling? Rating of transformer, KVA, MVA, right? Rating of generator, kilowatt, megawatt, right? So you are making generation in terms of S. Yes or no? Right? Do you agree with me or not? दबाव में मत बोलना, क्योंकि मुझे पढ़ा हुआ पुराना काफी टाइम है. मैं तुम्हें हो सके तुम्हें जल्दी पढ़ा होगा. हाँ या ना? एस में होता है या पी में होता है कि क्यू में होता है? इट इज नॉट इन क्यू इन एनी केस, राइट? So you may have a confusion between P and S. Agreed or not? Okay. Just try to find out the this specification of a alternator. Please try to find out. Open your mobile. Right? Just try to find out the rating of a generator. काउंट करेंगे ना. दिस इज हैंड्स ऑन ना. है पक्का? केवीए और किलोवाट includes the maximum output. Okay, but kilowatt is always dependent upon cos phi. Agreed or not? These are the synchronous generator, asynchronous motor. When we will talk about generation, we will talk about only SG, synchronous generator, that mode. Right? Okay. Next block is transformer. Transformer is also in MVA, KVA or VA. Agreed or not? Okay. So just now come back to the triangle, power triangle. Okay. So this power triangle says that at this particular moment there is one P, Q and S. Right? We will make S constant. Clear? Now do this. No constant. Okay. Make this P constant, because P is the consumption which is happening at that substation. Agreed? And for that P, which is in kW, kilowatt, right? You are getting the price of electricity kWh per unit, rupees per unit. Agreed? So this P is fixed. Yes or no? Okay. Now what do? You just make it as P Q1 S1. Mark it in that triangle. In that triangle, P1, sorry, P constant, P Q1 S1. Right? Now, consider Q2. Q2 is larger than Q1. Draw or change that triangle only. Or you may draw some new triangle also, but on similar base. Clear? So now Q2 is larger than what? Q1. Okay. Now compare the power factor for both cases. It is poor when Q2 is more. Why this is poor? How can you conclude this? Cos phi. Right? Which angle you are talking about? Power factor. Agreed? Power factor means phi is increasing. So S is also increasing. Yes or no? Means when power factor is bad, you are supplying more S. Agreed or not? Okay. Now you control reactive power. Consider Q3 less than Q1. Make it lesser than Q1. Means you are taking care of reactive power, right? And you are supplying this Q locally at substation through the capacitor bank or some other mode. Clear? आप बताइए, आप बताइए, अभी तक करंट पे जा ही नहीं रहे हैं. We are simply talking about theta, P, Q, whatever that is. हाँ. जी. हाँ. इसका मतलब हम आई नहीं कर रहे हैं. तो ये हमारा KPR वेरी. सर अभी हम केवल वी आर टॉकिंग अबाउट Q. Right? There is Q. Then we are, if we go in detail, so there will be two different components. One will be IR, one will be IC. Right? IC or IL, whatever that is, depending upon the nature of that. Right? So what we usually have as the common notation that our loads are inductive in nature. Right? So what they are doing, they are IL in nature. Agreed? Right? And just to cancel the amount of this capacitive current, sorry, this reactive part, we add these capacitors. Right? So they oppose and neutralize and try to dominate. Agreed or not? So this part is reduced, Q is reduced, means when you added capacitor, this inductive part of the Q is reduced. Clear? So what is for the same P, now you are having lesser S. Agreed or not? What is the case here? Power factor improved or not? Improved. So for when this is for benefit of whom? This was for the benefit of the supplier, right? Now for the same revenue in terms of kilowatt hour unit cost, right? He had to supply or he has to supply lesser S. Agreed or not? Clear? So that's why this was usually in earlier days this was done at clear. But nowadays when the power electronic control devices are there, your LED bulb or this tube light, whatever that is, they are taking care of this power factor at instrument only. Clear? So this is the second aspect. But yes, agreed or not? Any confusion is still there or not? Clear? So this was the reason why we used to add capacitor at the substations. Clear? But these were the questions of the numericals of the past time. I do not know. Have you your ignorance shows that you are not dealing with such questions now. Is it so? Chaliye sir. So we all know that these generators, we will come back to this, they provide no natural inertia but can emulate this inertia through control techniques or some software, right? So when we are saying that we are adding this control techniques or we are trying to adding some software application over here, so I will again go back to that 3D that was not completed. Those 3Ds are decarbonization, decentralization and digitalization, right? Or earlier I used the sequence. Decentralization means generation at the load point. So when you are doing generation at load point, it means the requirement of the distribution system is reduced, right? So again the problem of distribution losses is gone, right? And that's why there is a new terminology called distributed generation or DG, or that is also called DER, distributed energy resources. Clear? Now there is again one more question. When I am saying DER and I am saying IBR, right? And I am saying that both of them, they are being used for or they are serving the purpose of decentralization. Agreed or not? Then why I am taking these two names? What is the difference between DER and IBR? Can anyone tell? DER is distributed energy resources or DG, right? Second is IBR, inverter based resources, means power electronics is there, right? And again I am using the term renewable energy resources, right? So all these means question is these are three terms, not different terms. Are they same or they are different? Tell me. Same? Different. What is the difference? Hmm. PV is an IPR. PV is an IBR. What is no type? Nothing like type. Hmm. They do not require. So they are synchronous generation they are using. Hydro is using synchronous generation, na? They are using alternators. They are not, the water is not falling on a inverter or this converter or some solar plate. Water is falling on a turbine. Turbine is rotating. This rotating turbine is having some mechanical power output, and this is connected to alternator. That is a synchronous generator. Clear? So that will not come into this category, in this category. That is synchronous generation. Not agree. Agreed or not? Then what is the confusion? Your expression says that you are not convinced. How can you say that? This is renewable energy, right? That's why I am repeating the terms again and again. This is this, this is this, this is this. What is the difference in all these three terms? Right? Now there is a term DER, distributed energy resources, or distributed generation. Clear? Microgrid definition says distributed generation. Microgrids are comprised of distributed energy resources or distributed generation. Right? That doesn't limit it to renewable energy resources. If you go for the definition of microgrid, the standard definition, IEEE definition, or US government definition, they are the initial definition of earlier days, or SIGRE definition, right? So these are the few things where microgrid is defined. Clear? But that uses distributed generation, not renewable energy resources. So let me make it clear to you. When we are saying distributed generation, so distributed generation may contain that solar panel also, that wind turbine also, that battery BESS also, right? That diesel engine also, right? And some turbines are also used, right? Small turbines, not fuel cell is also there, right? So this is a mix of renewable and non-renewable, right? So if you will read further, you will find that you can say that this renewable energy resources or RE, renewable energy resources, is a subset of DG or DER. Agreed or not? So this is the difference. So try to find out the definition of microgrid. There are three definitions of microgrid, standard definitions. Try to find them. Definition of microgrid. क्या हुआ? कॉपी में लिखो ना, सर्च मत करो, अभी बाद में लिखना. Definitions of microgrid, right? And if you will take interest in that definition, you will, if you want to go deeper in that, you will find that this definition of microgrid, which has been released officially, right, and which is followed by the word that qualifies the Edison's first experiment of Pearl Street, right? The Edison, when 1882 or something like that, he did that commercial setup, very first commercial setup, when he commercially made available the electricity on that Pearl Street, right? It was some 11 miles long street. On that, he using the diesel generators, he generated electricity and provided on that street. Clear? And if you go by that definition of microgrid, that definition has certain points in that, of that geographical boundaries. They talk about resources, limited resources. They talk about they can be used in a grid connected mode, or what is second? Islanded mode, right? In both modes they can operate, right? So if you qualify those conditions on that experiment, that is established, that experiment was a microgrid thing. Clear? There are n numbers of papers available on IEEE Explore, where you will, there is a column called history, right? You read that. Very small pages sometimes, but very informative. They will take you back to the history of the electricity, how it was started. Clear? and earlier generation was DC only. Then how and why we shifted to AC, that is also recorded there, and in what conditions or in what situations we are again coming back to DC. Presently what we are talking about, mostly our loads are DC, right? But as the supply available is AC, we are again converting it into DC for our uses, right? So here all these IBRs and other converters, inverters, they have a role. Clear? So that is a different story. Okay. देर तो नहीं हो रही है अभी हमको, हैव टाइम ना, ठीक है सर. So these inverter based resources, they have key characteristics. They provide no natural inertia that can emulate grid services. Grid services can be taken as inertia, voltage frequency regulation, black start and islanding capabilities, right? Note down these services and try to know about them. What are these services, right? What is black start? What is islanding? You must be aware with this because you are hearing about this since last few days. Okay. Second, they replicate these functions through control, different control methods. They may be loop control or something like that, right? Synthetic inertia or voltage regulation they can provide, and that's why they are important. They have importance in this new type of new system of electricity generation. Then comes rapid control response. Using these control techniques, they are capable of providing the solutions of the problems, right, in milliseconds, right? That is their response time. And these are fully programmable operations. At what level they have fixed some certain this control techniques are involved, right? And frequency, voltage, power factor, they all are controlled in millisecond response time. Then they have this fault limiting capability in them. So they have this, whenever there will be fault, either way they will be isolated or that will be repaired automatically. And these IBRs have two different types. One is grid following, that is GFL, and second is grid forming, that is GFM. We will use these terms GFL and GFM in our further discussion. Now, as I told you, we have a second slide which having this differentiation in wind turbine type 3 and 4. So this is the difference. Type 3 is DFIG, that is, we have read about that. That is doubly fed induction generator. बेटा ये स्लाइड्स की फोटो खींचने में तुम डाइवर्ट हो रहे हो इस समय, ठीक है? दिस ऑल इज अवेलेबल एज अ यूट्यूब लेक्चर दैट इज गोइंग टू बी परमानेंट रिकॉर्ड, right? And second thing, always prefer to note it down in your notebook. Whatever you note there, you at least that is going once through your hand, right? Or through this ecosystem of brain hand equilibrium. Clear? So again, when you will have this notebook, at least you will study about that, or you can ask to me again. So this type 3 is DFIG, doubly fed induction generator, and type 4 is full converter wind turbine. Clear? This is the difference between this type 3 and type 4. Type 3 was having certain limitations, and that is the reason type 4 wind turbines are mandatory in certain power systems in specific countries. Agreed? So what is the difference? First feature is generator grid connection, right? Only 30% power is processed through rotor via converter, or stator directly to grid that handles 70% power. And this 30% is only managed or controlled or adds flexibility in the wind power generation, right? Whereas in case of type 4, the generator is fully decoupled and all power is processed through this converter. So it is fully controllable. Clear? Second point the same, that is the speed control. And in that case, when the control is applicable on the rotor part, in first case, so only limited range variable speed is available, because you have a control on the almost 25 to 30% of power. Where, but in case of second, you have a full range control. Next point, bit interaction is, so this type 3 is having GFL, type 4 is having GFM. Control over active and reactive power, again partial is there, so this is indirect control. Direct control is only on 30% generation, remaining is indirect. Direct and full control on the complete thing. Fault right through capability, okay, note it down. What is the term? What is the meaning of term? Fault right through capability, FRT capability, right? So please try to identify these terms in between. What is the meaning, right? Otherwise, I am telling a story about Ram, Sham, X, Y, Z. You must be known with the characters, right? So these are the participants of this story. So what is FRT? Please be aware about this, right? If not, we will discuss again. So this capability is limited in case of DFIG or type 3. Type 4, this is strong capacity is there. GFM or black start capability, this is not supported. That is fully supported, means type 4 can or may supply electricity to a dead grid, right? That is the condition which we call black start. Clear? So black start is that. Typical use is type 3 is older wind farms and cost driven projects, because type 4 has a higher cost, right? So low capacity or low capability, low ratings, still they are available in DFIG. Where the commercial ratings are available with full control thing, they are this type 4, and mostly offshore winds which are not easy to access every time for control or for maintenance, etc. There only these type 4 wind turbines are preferred. So why we are having this much discussion about the IBR, right? Earlier there were confusions ki no, this thing is not going to happen. Whenever we have something new in our system, first we have a doubt on that. Is it going to happen or not? Right? Very long back, in 87, when I was taking my admission in BTech, at that time we are that doubtful, it is computer science is going to be a successful branch or not. Most of us didn't prefer that, right? But I am a graduate of 91. In before 2000, every person who did BTech computer science, they were doing very good. They were comparatively much better, you can say, or economically, not in other ways, right? And when this 2000 year come, that was a problem like Y2K. Are you aware with that problem? Have you heard of that? Of course, basically, most of you are born after 2000, I think. Most of you, right? So there was a problem that was called problem Y2K. Means earlier it was 98, 97, 99, and how the computers will behave when this 2000 and that series will open, right? So that was the problem Y2K. Clear? So similarly, what is the demand today? After 87 to today is 25, almost 27, 40 years, right? And after some time, every boy wants to go for the computer science only, right? That is also not a good trend. I support that. It is not a good trend. It is a very dangerous trend. Anyhow, I am thankful that you are studying electricity, because this power is very much important for the run of this, for running the show in the society, in the city, in this globe, right? So that is very important thing. So in the same way, there were hue and cry about how it is possible that all the grid is going to have zero inertia. Means no generation through coal, no generation through synchronous generators or synchronous machines, including hydropower. Clear? But these are the few examples where this Hawaii, USA, they have this 100% IBR generation they had with for some time, for short durations, they have maintained that using this battery energy storage, advanced inverter control functions, and careful dispatch planning. Means you have to make the electricity dispatchable, right? As I told you earlier. So all this energy systems control, whatever that is, that was properly managed. Hawaii targets, Hawaii means Hawaii Island, they target 100% renewable energy by 2040 with real world IBR trials underway. Second, India is also having their own targets, right? And we are having a target of achieving this net zero by 2070. Are you aware with this or not? India is also having its own targets for generation of solar power and wind power by year 2030, right? And in end of every month, Ministry of Power, they release a data on their website how we are achieving our targets, right? And at the end of every month, they show it, yes, we are ahead of our targets, right? So it is very much possible if whatever we are targeting for 2030 or 2070, we are going to achieve them quite earlier. Clear? Second option example is Ireland. They are operating with more than 75% generation of IBR, right? Means renewable energy based generation is there, which is using these power electronics in this processing of electricity. Number 3, most of the countries, especially in Denmark, they are having this wind power generation capacity, not generating, right? They have this wind power generation capacity of 120% of the maximum demand of their country, right? अगर उनकी if they have a requirement of 100 megawatt, they are generating 120, and that's the reason most of the countries in Europe which are near this seaside, and they are having this good wind profiles, they are generating very large amount of electricity, and the whole Europe, they are interconnected. And that is the reason sometimes they are enjoying very low prices of electricity also, right? Germany, they are dependent on solar power, right? And let me tell you a story. In Germany, some 2-3 years back, I do not remember the year right now, or maybe 4-5 years, right? At the end of the year, in the month of December, right? December was the month when the Christmas is there. Agreed? Christmas is a festival which they enjoy a lot, and most of them are traveling. No office, no business, right? And once they are traveling, so this residential load is also down. Clear? And here comes I will cover this topic, grid codes also, and here comes the role of grid codes. So you must be aware with the term grid codes also. What are the grid codes and how much important role they have in the operation of grids, right? And especially in those grids which are IBR rich. Clear? Again, IBR rich means this volatility of generation is going to be different. So what happened? Through this prediction, they found that the solar generation is going to be very high in some particular days after 25th. That was probably 26th or 27 or something like that, right? So when the generation is going to be very high, consumption is going to be low than average. It means there is going to be some unstable things in the grid. So just to avoid the damage, either you have to disconnect the things, and once they are disconnected, again the problem of synchronization, etc., right? So what method they adopted, that is also a legal method nowadays. They published that for this particular duration we are going to offer, or they published means they communicated this to the customers, right? For this much duration, or for this much on these dates during these hours, right, we are going to have this negative electricity prices. Means if you are going to consume the electricity, you are going to earn some revenue, right? Dr. Prashant will tell you much better regarding this because he is a man of electricity market. But this is the story which I have read, and that was a very new thing for me at that time, right? So that's why I want to share. I hope you also have listening it first time. This is the terminology also available in the electricity market. Clear or not? How many of you are aware with this term negative pricing? Except Afzal Tiwari and Mahima. You also know. Good. So ठीक है भाई, इन तीन आदमी के अलावा बाकी लोग नहीं जानते थे ना, सुना कि नहीं सुना ये बात? दिस ऑल्सो हैपेंस, तुम भी जानते थे, ये सब जानते थे यार? ये तो भाई देखो बारी बारी तैयार होते जा रहे हैं यार। चलो कोई बात नहीं, जो नहीं जानते थे उनके लिए जानकारी है, जो जानते थे वो और जाने इस बारे में कि what parameters are there, such parameters are there. Then this is this is also a part of European grid, Irish grid. This has hit instantaneous IBR shares up to more than 25% and aim to 95% plus for by 2030. Implements SNSP limits. SNSP is system non-synchronous penetration threshold. At this stage, we are not going in detail of this term. This is just for your knowledge, right? So, and as the total generation is non-synchronous, so they are having this synthetic inertia via wind and battery energy storage, special operation controls for frequency and voltage. So why we are discussing at this point here? The purpose is to just to tell you that high IBR operation is no longer theoretical. This is taking place in practical, right? So high HBR grids are already being operated reliably. When the right mix of control strategies, storage required for dispatchability, right, and grid codes, even 100% integration of IBRs in the grids can or do work reliably. Clear? So next term is grid codes. Why the grid codes are evolving? I told you grid codes, right? And in Europe, most of the countries, they are having their own grid codes, right? Because same thing is not going to applicable. One what is that saying? Ki one doesn't fits all, right? One solution doesn't fit all. Clear? So there are some standard of global or international level, and each and every country, they have modified it as per their requirement, and that's why this is the reason every country is having their own grid code. German code and other European countries code, they are very popular. So what are grid codes? Grid codes are basically checklist. When you leave the room or your home or your room for the examination, you have a checklist. I card, yes. Pen, yes. Similarly, grid code is also says voltage in this range, fault, no, current, this much, power factor, this much, and they are more important in case of faults. Means something unavoidable and unwanted is happening in the grid, right? In that case, you can monitor, yes, up to this point of operation, we will have to wait. We can operate, right? And once this particular line is going to be crossed, then we will disconnect this particular portion to save the remaining portion of the grid, right? This is the, or in what conditions something disconnected earlier or some new generator that can be added so that the balance of this running system is not going to destroy. Okay, whenever there is a new load, big size of generation or big size of consumption, they are added in the grid. They have to pass through these grid code requirements. Agreed? So the purpose is define the technical and operational requirements for all grid connected generators. Grid codes are issued by grid operators or national or international regulatory authorities. Focus area is normal as well as abnormal operation, both, right? Abnormal system conditions, and they measure fault response, voltage and frequency behavior, right? We will take a consideration of term rate of change of frequency in our later discussion. That so his response of frequency behavior, yeah, how this frequency is changing, that is also considered here. The key function is ensure that it remains safe, stable and reliable. Stability is very important. Either it is a synchronous grid or non-synchronous grid. You are aware with the course. Stability, I hope you all are aware. Most of you are aware. Agreed? Then, especially during disturbances or contingencies. Why grid codes are changing? Grid codes are continuously changing. They are evolving continuously with the new scenarios upcoming in the grid, because new type of loads, new types of generations, new types of storages, they are connecting in the grid every day. So the power grid is shifting toward IBR based generation. Traditional codes were built around synchronous generator or synchronous machine operation with natural inertia of that machine and the grid support. Clear? Modern power electronic based inverters need explicit instructions to behave like supportive elements, and those instructions, they come from the grid codes. Clear? So what are the new expectations from the grid codes? What they shall, भाई आप एक रेफरेंस किताब खोले, भाई ये देखना है, इसमें हमने आपसे कहा FRT देख लीजिए, तो सब FRT तो है, लेकिन इसके क्या रिक्वायरमेंट्स होने चाहिए, क्या कितना क्या क्या वैल्यूज होने चाहिए, that is not mentioned, right? So that is the expectation from the grid codes, which are new in nature. What is the fault right through capability? Reactive power support during faults means abnormal operations situations, inertial response capability, and voltage source behavior or grid forming ability. So these are the new expectations. The global challenge is several grid codes, they lack detailed definitions for IBR behavior, because nature of IBR is changing every day. Clear? Controls are changing every day. No uniform requirements for GFM control. Inertia emulation means copying or developing inertia, or harmonic absorption. Harmonics is also a problem when you are going to introduce power electronics in the grid, right? Definitely this is going to have some power quality issues with it, right? You have to take care of those aspects also. Then enforcement often falls to individual TSOs. TSOs are transmission system operator. This concept is present in India also, and very soon we are going to have these DSOs also in the system, that is distribution system operators, right? So who are new to this term, they must read this, what is TSO and what is DSO, what is their role, right? And how this, why this DSO is going to be or they are going to appear in our Indian power system. Now what is the need here, and then you understand what is actually happening in the power system nowadays. So IBRs can behave differently, and in different countries, different scenarios, different types of IBRs. right? And grid codes are evolving to push them toward grid forming behavior, or GFM. So this is the comparison of this grid following or grid forming IBRs. Frequency reference, this has been compared on the aspect of frequency reference, voltage source capability, synchronization, inertia emulation, fault right through or FRT, black start capability, control architecture, rolling weak grids, real world adoption, and suitability for 100% IBR grids. Most of these points we have already discussed in our discussion, right? You can just go through this table, right, and try to conclude कि whatever we have done is summarized here or not. If any new point is there, you can ask. ये वाला था. Thank you, bhai. Thank you. Any question? Can we move? Weak means what? Inertia. और क्या हो सकता है? Electricity cannot be weak. Either 10 volt or 20 volt, 100 volt, whatever that is. Yes or no? What is more dangerous, like voltage or current? Sure. They are equally important at point of consumption. I am talking about danger, electrical safety. Which is more dangerous for the human being? Electrical higher current or higher voltage? Why? Read about it. Okay? You just Google electrical safety, right? And always trust on the reliable resources, right? So I always suggest for the IEEE Explorer. You will immediately find which is more dangerous, but trust on that official document which is available on the IEEE Explorer. Clear? Then have some questions. We will discuss it tomorrow. I'm open. Clear? So this particular table concludes that grid forming IBRs are essential to grid as per the new requirements, right? Because of these advantages which are being listed here in this table. Clear? And they are essential to grids with very high or full IBR penetration, as we are targeting towards that 100% penetration. They replace the core functions of synchronous machines in software, making them the foundation of tomorrow's stable and fully IBR based grid. Challenges in high IBR grids. What are the challenges? In terms of stability, protection, and control. Because these are the three aspects with which we have to handle to make the grid stable, safe, and reliable. Clear? So, challenges are no inertia, how to handle it, no rotating mass, and when rotating mass is not there, so this rate of change of frequency is going to be very high. Yes or no? So, that is unstable frequency. That problem may cause due to lack of inertia. Second is weak frequency response, means GFL, means grid following IBRs mid column, they do not inherently regulate frequency, right? GFMs do. Loss of natural damping. Traditional synchronous generators, they provide passive damping. IBRs don't, and they require active damping through control algorithms. Clear? It is possible to have, but for that we have to employ control techniques or active damping methods. Voltage instability means weak grid, that goes to poor voltage support from IBRs. Dynamic weakness, that is fast but fragile behavior, and problem is it is difficult to model. When modeling is difficult, then definitely the finding solutions are also being difficult. Clear? Then protection and control challenges, low fault current. IBRs can not supply high fault current due to limitation of the current capability of the components. Clear? Then comes relay misoperation, means legacy protection techniques which are for mostly for the AC grids, they may fail to detect IBR faults. Coordination complexity, IBRs are dispersed, means distributed generation. Clear? So varied controls, latency, bandwidth requirement for control, because it is very difficult to have a centralized control for them, right? So you have to put this control at local levels. Small signal oscillations, the control interaction is in the band of 1 to 15 Hertz. No unified load sharing, means no frequency based governors like coordination. So this is a challenge to handle. In high IBR grids, system security depends not on inertia because it is not present or any hardware, but it depends on algorithms, faster control, and coordinated standards. They control and they try to maintain our grid reliably for the reliable operation. So why the GFM is the way forward? Traditional IBRs assume a strong grid for synchronization and fault support. In high IBR or weak grid system, definition is here. Clear? GFL modes fail to maintain stability, leading to protection issues, voltage collapse, or poor frequency regulation. In GFM IBRs can directly address lack of inertia by emulating inertial response through control. Grid voltage collapse, they can be controlled to act as a voltage source right through capabilities. So through control they can remain stable throughout the fault and normal conditions, and they can provide this they have a capacity of providing this black start flexibility, means they can energize dead grids independently. Clear? Write down a term. What are the ancillary services? There is a term, ancillary services. Read about it. What is it? Okay, what is it a single ancillary service, means single service, or it is a set of services, means multi services are coming under this umbrella term? Clear? So please read about it. Core capabilities of grid forming IBRs, this grid forming IBRs, they have a feature of voltage source behavior. They provide controlled magnitude and phase, and that enables grid forming. Virtual inertia they can provide to stabilize frequency and lower down the rate of change of frequency. Means once you are adding the inertia synthetically, the rate of change of frequency is going to come down. Black start capability, reactive support during faults. So this reactive support that is going to support the voltage or voltage drop, it can be taken care, right, and contribute to system strength. Harmonic and unbalanced mitigation they can do, right. So they can provide this waveform stabilization, or this waveform can be maintained, or quality issues can be removed. Then comes first swing or emergency damping, means they contribute to transient grid survival after major disturbances. Means damping they can also provide. Means whatever were the problems with the removal of inertia from the power system generation, that can be taken care very efficiently with these GFM based IBRs, right. So they are nowadays can be treated as a complete solution of this problem, right. The only way is how to provide or manage a better control of them, right. So next solution, next research is on how to develop the better control techniques for using these GFM based IBRs. Clear? So practical challenges in implementing GFM is current limiting constraints are there, because these polyphonic controls, they can have some current limitations with them. So they can typically only operate up to the 110% of the rated currents of the system, and sometimes fault currents are much more than this 110%, right. So that is the issue. Limits fault support and inertia injection during events. Simplified control models. GFM dynamics are based on mostly first and second order systems, right, but practically they are not, right. These control systems or their control models, they are typically having much more higher order, and using this what this they use, Deepak and team, order model order reduction, right. They bring it to first and second order. Unlike system generators having richer dynamics affecting small signal and transient stability, जो कि SG ना होने की वजह से नहीं है, that is provided, that is a challenge for them to provide. No global GFM definition exists right now. There is a standard I will talk about that has been introduced in 2022, but still TSOs, means transmission system operators, who are the responsible persons for operating these grids, right, means major portions of the grid at the country level, right, they face this problem sometimes, right, and mostly these problems are more dominant at the points of interconnection when the electricity is going from this country to that country, right. So those point of interconnections, if the countries are having the different grid codes, then this is definitely an issue, right. Suppose you are going to solve that problem temporarily at the point of interconnection, but if the operational requirements are different, so you cannot be very sure the problems are not going to appear in future at some different point of time with some different set of operation constraints. Clear? So that is the issue. So that is written as inconsistent grid behavior. The control complexity, again, when you are going to add damping, active damping or something else, right, all the behavior you are going to emulate or imitate there using through control techniques or software. So definitely that is always a control complexity. We will explain it further in the next slide. The GFM closes the functional gap. However, we can say that GFM is a possible solution which can be explored further to bridge the gap between this inertia and non-inertia based power system. The design level control complexities in grid forming IBRs are GFM behavior at the same points, just some you will find some one or two new points in that. This GFM behavior is controlled or software defined. Parameters like inertia and damping are not physical but must be designed and tuned, means emulate. No use of PLL means phase lock loop is not there in GFM, it was in GFM. GFM must self synchronize as a voltage source. So that is also a challenge with GFM. Requires careful tuning of virtual inertia constant because it is going to affect rate of change of frequency. Yes or no? It is going to affect frequency. Damping factor, you have to tune that. Angle synchronization, you have to tune that because these all are required for the stability of the power system. So why it is challenging? Dynamic behavior varies with the system strength and topology. Why I am saying this? Because when we are saying that IBR based system means now there is no requirement of adding some 500 megawatt system in the generating station in the system. I will have 1 kilowatt. I am getting subsidy for this 2 kilowatt, 3 kilowatt and 4 kilowatt for this rooftop solar from the government at different rates. So as per my capacity, I will add either 2 kilowatt or 3 kilowatt or 4 kilowatt, right? So I can connect it to the grid. The local substation is also going to connect my system of rooftop with that. Yes or no? So definitely not today, but after some time, when this sigma is going to high, they are going to bring some difference. Otherwise, how much power a TV consumes? Television? How much power? 100 watts. 100 watt was a time when that was CVT. That was older time when there was a picture tube this size, right? अभी तो टीवी इतना पतला सा है, हाँ? चलिए पता करिएगा, मुझे आप सवाल सही है उसने भी जो किया, मैं छोटे और बड़े में कितना कंजम्पशन है डिपेंड्स. नहीं, साइज ऑफ पैनल से बहुत फर्क नहीं होगा. चलिए ठीक है, देखिएगा ये भी एक क्वेश्चन है. ठीक है, एज इलेक्ट्रिकल इंजीनियर आपको यू मस्ट बी अवेयर विद दिस कि हाउ दिस व्हाट इज द कंजम्पशन ऑफ this old fan and the new fan. New fan means when I am talking about BLDC fan, right? How much consumption they are doing. Most of the time, if I ask how does a meter work, meter means electricity meter, you will say yes, I know. But the meter which you know is nowhere installed right now. How many of you are aware with the smart meter functioning? Are you aware with it? You must, because you already done a course in the measurement, right? So you cannot say, no, I have read this old Sahani book and that's why I am aware with that. Net meter is there, yes. When I am talking about this thing, na, connection at the rooftop with using government subsidy. So there is net meter also connected in the power system. Here, you must be aware with these things. If you are having a meter, I think most of us have a meter in our home. Yes or no? Is there anybody who is not having a meter in his home? Right? So, you must know about the electricity meter, what it is doing. Right? When you have this, as I told you in the earlier days, this capacitor connection was the responsibility of this substation only. But right now, you will see that electricity meter is this long. Yes or no? A paper slip of some 2-inch width, but long maybe 12 inches or 15 inches like that, right? And you just try to read the entries in that. Have you ever worried about that? What are the entries in that? So now you are not paying only for the kWh, you are paying for n number of things, right? And that those things can be avoided, those payments can be avoided if you just see for which item I am paying, right? Maximum demand. Are you aware with that? Every consumer is paying nowadays. There is a power factor increase also there. I'm not sure are they charging for that or not, right? So just try to read your electricity bill. That is a very important thing, right? So please, if you are not having a bill, if you are having a meter but not having your access to your bill, please try to take it from your friend or your neighbor, right? And just try to understand it. What this electricity meter or this report bill, right? Which items it is having. Clear? Definitely it will add something new in your knowledge. Clear? So next comes the system operators, because they are the real persons who are responsible for the successful operation. And by this new additions of IBRs at different levels, right? Earlier these TSOs were responsible because these are new resources of generation. They were added at the transmission level only. But right now, when you are having this connection to the local level and distribution system also, so definitely the DSO is also become important. They have also become important, right? And very soon this Indian system is also, they are having TSO right now, but DSO is going to be added very soon. It was decided in 22-23 like that. There was a report of Ministry of Power. This IT Kanpur and REC Jaipur, they were NIT Jaipur, they were the part of it, right? So this Terry was also a part of that. So they have submitted their recommendation that DSO role, what is the role of DSO and why they are important in this new power system. So government has accepted that report. Let's see when it is going to be added in the Indian power system. So this DSO expectation is right through faults with voltage support, act as harmonic or unbalancing, support LFDD schemes. LFDD I have explained below. Then eliminate PLL dependence, right? So first is right through fault with voltage support that maintains stability, that is N-1 or N-2 reliability. Are you aware with this term? Are you aware with this reliability? A system is having n number of components. What is going to be how this is going to affect the operation of the system? If system is going to be operated with N-1 component, means some one is not working, or N-2, two are not working. Clear? So try to get information about that also. What is N-1 and N-2 events? Then act as a harmonic or unbalancing. We all know that power electronics is going to add something new. They are going to deform the wave shape, right? And this wave shape deformation is a power quality event. Any type of deformation in the wave shape is a power quality event. Then support LFDD schemes, means frequency remains recoverable in case of load shedding. Eliminate PLL dependence, phase lock loop, that is PLL struggles in weak grids. GFM, they are capable of self synchronization. So what is LFDD? LFDD is a protection scheme, basically that automatically shuts down when system frequency drops dangerously low, means ROCOF is high, clear, caused by generation load imbalance. Why it matters in high IBR grids? Because high IBR systems lack HY inertia, frequency drops faster. LFDD must operate quicker and more precisely, that is load frequency demand disconnection. Grid forming IBRs can help delay or reduce the need for LFDD by injecting virtual inertia in the system. Virtual inertia is going to change control the rate of change of frequency, right, and providing fast frequency support. Benefits of GFM in this LFDD, that it slows down the frequency delay by adding possibility of adding inertia. It reduces blackout risk, means system is going to be disconnected. Busy time, buys time for load shedding. In this process, during this time, you can decide, operator can decide which load is to be disconnected, which is the faulty part, and it will save the remaining system, right? Supports frequency based disconnection coordination. So in summary, you can say this LFDD is a last resort defense or a safety net when things go wrong. It saves the remaining part of the or the heavy part of the system, and it allows you to disconnect the faulty part or unstable part. So this GFM IBRs, they help make it smarter and more effective. There are three different types of classes for GFM control: class 1, class 2 and class 3. Class 1 is basic voltage source, no inertia or droop response. Class 2 adds droop control and inertia emulation or support, artificial support. And third is full dynamic support with voltage inertia, fault, harmonic and synchronization, self-synchronization, right? So all GFMs are not equal. Class 3 represents the most complete and TSO aligned version of the GFM behavior. Clear? So what this class 3 GFM IBRs can do, as we read in that summary sheet, that it can provide all those functions. Class 1 and class 2, they are not capable of providing all the functions, right? So these all functions, they are being supported, they are listed over here, they are being supported by the class 3 GFM. So where we are heading towards, right? Evolving global standards for IBRs. So why standards are important? We are coming to the last phase of the lecture. What are the standards? I hope few of you must be aware with this. What are the standards? And who are doing research or some advanced stage of the study, they must be aware with the standards also, right? There are standards for power quality. There are standards for the harmonics. There are standards for the several events in the power system, right? And most of the time, these standards, most dominant standards are either from IEEE in American part of the globe or SIGRI in the European part, right? And remaining countries, most of the countries, they participate in the formations of those standards, and then they try to align it with their own country's requirement. Clear? So IBRs are now central to power systems, but software defines their behavior. Software means control, that defines the behavior. Clear? And without standards, response to faults, voltage dips, frequency events can be inconsistent. So they are more like grid codes, you can say, right? The standards are for the grid codes are for the operation of grid, and the standards are for the devices, basically, you can say, right? So these are the grid code, these are the standards for the IBRs. Clear? So with all these capabilities which we have studied in last slide and second last slide, right? This clearly summarizes that GFM is a new baseline for high IBR systems stability. Do you agree with it or not? Means when type 3 is providing you all the features, so that is capable of making the system, power system, equivalent to inertia based systems. Clear? And even inertia based systems were requiring some specific type of control for maintaining the stability or maintaining the frequency response, voltage regulation, etc., etc. And all those things are being covered by these GFMs. Sorry, yes, GFMs. Clear? So the key standards and global initiatives are, in USA there are different bodies, FERC, NERC, they are there. And this IEEE 2800 standard is also there, which was released in 2022, right? So this IEEE 2800, that contributes performance based IPR specifications, voltage, frequency, FRT and harmonics, right? And these NIRC guidelines, they are operational guidance for IBR fault and voltage events only, right? So they are not the complete one. Europe is ENTSOE, that is network code revision, that is underway, it is going on, drafting pan-European GFM specifications for IBRs. Then comes the Australia, the grid forming requirements. Australian system is having Mostly they are dominant with the solar power systems, right? Because they are having the solar requirement, the solar setup is more, and it is their problem also. Sometimes there more research is focused on these things. Means solar related problems. Clear? Then comes the Ireland, that is the grid, SNSP rules and GFM mandates. I already told you what is SNSP, that is system non-synchronous penetration threshold. They are tying IBR percentage targets to GFM upgrade reliably, how much percentage of IBR can be increased. Why not to, or how can we make it to 100%? Then I told you example of this Irish grid also. They are trying for 100% by 2035. Then comes the UK, United Kingdom or Britain. Contracts for GFM services are there. They are under process, and they are procuring GFM for battery energy storage systems to stabilize it after the retirement of coal. Means most of the coal-based plants, they are very old, right? And now they are not going for reinvestment in the coal, and they are trying to retire them one by one, right? And if you go in detail of that also, what they are doing with the remaining space of that thermal power plants, retiring the coal means you are not going to make some tourism spot there, right? They are trying to convert it into a space for battery energy storage, right? Just look at it. If they are, just try to locate how many old thermal power plants, coal-based power plants, they are being converted for the battery storage, right? So this is also an interesting thing. How they are converting those thermal power plants into battery storage locations. So this IEEE 2800 and why it matters. This defines maximum performance and interconnection capabilities for IBRs in bulk power system. They are applied to all IBR technologies, means all sort, right? And they are going to the limit of HVDC also. Focus areas are voltage and frequency right through, reactive and active power control, dynamic voltage support, fault response, and harmonic management. And they ensure IBRs behave like grid supportive assets, not just energy sources. Means they are emulating the grid similar to the older version of the grid with proper control, reliable operation with maintained stability. What does IEEE 2800 require from IBRs? What information they need and what actions they demand, right? Ability is frequency right through, and requirement is to stay connected and inject power during deviations. Clear? So grid codes of the European countries, as I was asking, every country is having their different codes, right? So they decide at what point of this code, there is a grid codes plot, at what time of this plot you can enter in the grid or you can leave the grid. This is a mandatory condition for the IBR based generating stations, means these DGs. Clear? And IEEE 2800 is a next stage in that series or in that direction you can say. Voltage support, maintain dynamic, and this inject power during deviations, when to connect, disconnect. That was the reason, that German example I told you, right? They have to give this negative pricing, otherwise they may decide to leave the system also. We will do the synchronization again, but it is not that easy from the regulatory point of view. Voltage support, maintain dynamic voltage, reactive power during faults, fault right through, that is right through low high voltage events, support recovery, inertia emulation, respond to rate of change of frequency using control based virtual inertia, harmonics and negative sequence voltage and current, means unbalanced situation. Agreed? So mitigate system distortion, act as a sink to harmonics, active and reactive power control, precise power modulation per operator command. So these are the interconnection process for the IEEE 2800 standard. It gives you how this connection and disconnection of the IBR based system will take place, right? So this we will discuss sometime later in detail. This is the global alignment with the IEEE 2800 principle. USA is IEEE 2800 is active right now since 2022, becoming FERC aligned. NERC supports integration, testing ongoing, means limited only. Europe, ENTSOE drafting GFM specs, they are in alignment. VSM integration is alignment. No pan European Union standard yet. So they are trying to develop it. As I told you, they are in process of development. I told you when we were discussing this pan European standards. UK, ESO contracts GFM by yes with the 2800 like specifications. This UK also has, means we are talking about the alignment. Clear? And the operational projects like Harmony and GSRP, they are the projects name through which they are trying to develop themselves. Australia, AEMO mandates GFM for BESS grid support. They are only allowing this type 4 wind turbine in their system, no type 3 or similar to that. This test beds like Honsdale follow 2800 style requirements. Clear? So this Australian grid network is very interesting. In European side, you can find this German grid code very interesting. They are the toughest code, right? Means sometimes whenever you submit something for research purposes, they give you a comment key, just test it on the German grid code, right? So that for FRT or LVRT, whatever they are, they try to test on that grid code only. That is the final status. Yes, if it is working on this, it will work anywhere. Then comes Ireland. SNSP roadmap requires IBRs with GFM capabilities. Remark is GFM is enabler for more than 95% penetration of these IBR based systems. Challenges, they are modeling burden is very high in case of this RMS, EMT, fault and dynamic test. So all these need to develop models for these studies. That is still either ready to start or they are going to happen but not present yet. No unified global certification process is there. Cost for inverter upgrades, testing labs, tuning, etc. They are very high. User pace to adoption varies, and definitely the risk compliance gaps are also there. So need for TSO coordination on model validation and benchmarking is still a challenge. As I told you, whenever there is an interconnection issue, they may create some problem. So unless until they are not going to an agreement on different codes at certain points, this problem is definitely going to persist. And so current gaps are no harmonized compliance or testing framework for GFM control, lack of common models for small signal and EMT analysis, difference in the FRT threshold for different countries, harmonic handling and inertia specifications between countries, need for convergence on control tuning benchmarks and validation metrics. The standards are no longer optional, they are mandatory. The future of reliable power grids lies in a standard that requires IBRs to behave not like as a component in the system but as a asset in the system. These are the few references you will find, and definitely if you want to go in detail and want to have some knowledge, I have not went into in detail much detail of everything. I have attempted to give you only a strong overview of all the aspects, different possible aspects, right? It was more like a buffet system. If whatever area you find interesting, you go deep in that. Clear? So this was all about this, and if you are more interested in those things, you can find out different magazines, right? This power and energy magazine, most of the time you will find that they are the only references I have used, right? And these are the energy magazines which are giving you the knowledge of the things much in advance. Basically, research publishes after it's happening and reviewing. process. So most of the time researches are, they are 1 year minimum later than the happening, right? And these magazines, they are giving you updated knowledge, right? So if you are an electrical engineer interested in the domain of power and energy, power electronics, or in general in engineering systems, you can go through these IEEE magazines. Most of the time they are available, uh, freely available on the website, or you can approach your friends who are the members, through which, through them you can get these magazines. And if you are not finding it anywhere, you are finding something interesting, you can come to me, right? But these are the magazines. Try to find out, every quarter they usually publish. Try to focus on any one or two article of your interest. It is not possible that everything is of your interest. Yes or no? Right? So whatever is you are having interest in, that you mark that, try to explore in deep in that, right? And then definitely when you are going deep in that, you will feel yourself attracted to the connected things. And this is the way by which knowledge grows. Clear? So, this is the thing which I want to share with you, right? First thing is, knowledge always comes by the reading. ठीक है, कि यूट्यूब पे देख के कोर्स अगर कवर किया भी है भाई, तो प्लीज ट्राई टू फॉलो वन स्टैंडर्ड बुक फॉर ईच एंड एवरी सब्जेक्ट. That is mandatory thing, right? Even if you feel that it is not important, on my advice, have a copy of any standard textbook with you. So whenever you feel ki I shall clarify myself on this point, there shall be someone to support you, and this support, the best support you can get by some good book only. ठीक है, ये this is a global problem nowadays. Whenever you are having some PhD interviews or some interviews somewhere else, and it is asked which book of control system you have referred, right? And candidates are not having the answer for that. And if someone tries to play, yes, I have read this book. So never forget that there is expert on the other side of the table who is dealing with you, right? So sometimes if you are not knowing something, to accept that is a better answer than try to emulate like this GFM ki yes, I can do this. That is always a wrong choice, right? So this is an advice for you. If you have any questions, we can discuss. Any questions? Or something like that which you feel that I shall add in this these slides. Sir, everything was covered, but this point was not covered. What do you say about that? But you have covered all the purpose. Yes, that's what I'm saying. That I have just offered you a buffet, right? I have attempted for that, because all this combination was all possible aspects. I tried to collect it. What maybe in which dimension you can go deeper, that you have to select. And if you feel that I can help you in, you select one thing, right? If you feel that I can help you in that deeper journey, I will be there, right? You can write me on this email ID. Acha, email ID is not here. This is ashish@mnit.ac.in. Ashish is having double E, MNIT is having double N. Clear? So please take care of this, otherwise there may be a possibility that mail is not reaching. Right? You can contact me, you can ask questions anytime. At any point of time you feel that this answer I shall give you this answer, I will be there. Clear? I have also these few tutorial questions I have also developed, Prashantji. If they want to take benefit of these questions, right? I'm not asking that they shall answer it to me, but definitely if they just go through these questions, they can review whatever they have read, and they can also identify that you are asking it here but not covered in the lecture, right? So this thing you can take care of it, right, sir? Any questions? Any Wonderful audience. I was not. This all will be covered in 5 minutes or 1 hour. Only 20 slides were there, but they have shown. Initially, right, and then after some time, inertia can be removed. Right. What is the useful part of that? That can be to make a better system. Try to understand this analogy, and this fits. Right. I'm not saying that this inertia of now shall finish today, but shall finish when this inertia will start participation. Right. Important. If we are in discussion, so decided. Right. It is not too much knowledge. I'm not having any knowledge. I'm just disseminating from somewhere. Made this to you. Right. So this is participating with me in the discussion. This may be a better also. There may be certain questions answer at this instant. Right. I will have that question. I will bring that answer for you. Bilateral, yes. So, right, wherever you are, भाई तुमने 2 घंटे और एक सवाल नहीं आया तुम्हारे मन में, अपनी कॉपी में एक एक सवाल लिखो, एक सवाल लिखो, कुछ भी लिखो कि नहीं थी सर आपने जबरदस्ती पढ़ाई हमको, यही लिख दो. हाँ, कंफ्यूजन. RER is what? IBR. Inertia based resource. Inverter based resource is to connect it with the grid. No. You are having a solar. You are having a solar calculator. Solar and if you want to integrate this or yeah, water is there. Otherwise, if something you are converting from AC to AC or AC to AC, both the cases will need converter or volt or otherwise or a current resistor involved here. So any point of time, if you need any power electronic based devices, okay, that will come under that only. Right? Yeah. I guess the actually broader concept in which you can consider the same as umbrella, and with that umbrella you can keep it. Right. So we are not talking about the direct connection of renewable energy based filter. Inverter, what is there? अच्छा आप ये बताइए, एक सवाल आपसे पूछता हूँ, पावर ट्रांस तो सबने पढ़ी होगी ना, हाँ या ना? What is the importance of power electronics? This motor we are using for motion since long, and we were having the very good control techniques for the speed control of motors. Yes or no? Clear? Then what this electronics has added in that? Everybody is trying about the power electronic based control. We are having a course also here, control techniques in power electronics. Yes or no? Right? So what wonder these two combination of electronics and control makes with the similar machines. Same machine is there. Yes or no? This new generation machines are coming in last 20 years, I think. But earlier to that, when electronics was controlling the older machines only. Agreed? So what this power electronics had added? What is its advantage? बोलिए. Low power consumption. Agreed? Why? So how this low value of current is definitely deciding the low power consumption. But main thing is that how this low amount of current is making the things happen in a similar way or a better way. Yes or no? ठीक है. आई कैन शेयर वन प्रैक्टिकल एग्जांपल विद यू. ये बात मैं आपको बता रहा हूँ 2003 या 4 के आसपास. इसको बंद कर सकते हैं भाई. अब रिकॉर्डिंग तो बंद हो सकती है ना. हाँ, ऑफिशियली इट इज क्लोज्ड. कुछ डिस्कशन.